Awesome. All right. Thanks for everybody for showing up. I really appreciate it, and a big thanks to the Hackfest organizers. This is I really enjoy going to conferences, and this one's really well organized. So thanks, you guys. Yeah, excuse me while I talk. I get a dry mouth, so I have to stop and get the water every now and then. All right. So my name is Patrick Fussell. Uh, I please take a minute to look me up on the internet. I always enjoy connecting with new people. So I am a penetration tester. That's my day job at least. I work for a company named PSC. PSC is primarily a PCI company. As I mentioned, my role within that company is as a penetration tester. I've been doing this for about 4 years now, and probably about 4 years before that as a security analyst. This is a really great pen test gig, particularly because of the methodology we have in place. We tend to use a goal-based pen test methodology, so I can do lots of fun post-exploitation work. And kind of a full disclosure for the community, I think most of the things, or I say nothing here is original from me. These are things that are inspired from people that I've met in the community, my coworkers. I have a really great team, and other friends I have in the InfoSec community. So thanks to everybody who gives me great information and helps me learn. So just to let you guys know what to expect here today, I want to go over a couple terms so that we all are talking about the same thing. Review a couple of common implementations for separating security zones, and then at the end I'm going to just go over a couple of what I would call secure design concepts that sort of relate back to those common implementations. So InfoSec is sort of rife with terminology and concepts that get used in lots of different ways by different people. I'm sure you guys have run into lots of buzzwords that everybody loves to hear, like DevOps in the cloud, that makes us all happy. So whether you're blue team, red team, purple team, whatever you want to call it, you might use these terms differently, causes some confusion. I'm not suggesting that the way that I'm presenting them here is the right way. I just want to make sure that we're all on the same page, so that what I think I'm talking about is what you think I'm talking about. So like I said before, PSC, the company I work for, is primarily a PCI company. For those of you who aren't familiar with PCI, PCI is the payment card industry. So we're concerned with protecting your credit card information. So often our goal for a penetration test is the cardholder data environment. So most of our pen tests take the form of starting from some unprivileged portion of the network that you might consider to be sort of the standard user, or maybe like a guest zone. This might be something like the wireless. We would then gain a foothold from there in your environment, and then escalate so we can access the portion of the network that has our target data. For our purposes, that's usually called the cardholder data environment, but this might be lots of different things depending on what the exact target is. So lots of organizations get hacked. I think we could all agree on that. And just a side note, this is a real book. You guys can get that on Amazon. Those organizations that get hacked, I think a lot of times some portion of the personnel at that organization thought that they were secure. However, if you go speak to any network or sysadmin, they won't tell you that their network is impenetrable. So there still seems to be a lot of buy-in to what I call, and I think I've heard other people reference the M&M security model, where we pretend like we're secure because we have a next-gen firewall. We're hard on the outside, but soft and gooey on the inside. So what's the point? Everybody can get hacked, or there's potential there for anybody to get hacked. Taking into account the high rate of success that in privilege escalation that we have within my team, and apparently the high rate of success that actual bad guys are having, I felt it was fair to push the initial system compromise type material out of scope for this presentation. And I'm going to kind of talk from past the initial compromise stage, so sort of an assumed breach standpoint. So a common paradigm is data and resources are classified differently from others depending on their use. We like to designate systems and resources with labels based on the roles. So QA, dev, whatever it might be, everybody's network's different. You might have a network segment that represents marketing and one for human resources. In terms of creating a security zone, the question that I think you should start with is, do the resources in marketing need to be able to access resources in human resources? Or maybe does IT need to be able to access everything in the call center? The answer is probably yes, but when you're thinking about the security zones, you have to ask the question. And for the purposes of this talk, we are reviewing environments where divisions exist that have security requirements of varying degrees. So we're talking about networks where everybody doesn't need access to everything, basically. If that's not the case for you, then I suppose your life is much simpler than everybody else. And finally, production is just a label for that we're using here for the zone that contains high-value assets. You might have several of these. They might serve different functions, but I felt like production was labeled that would make sense to everybody in referencing some zone that we want to protect from everybody being able to access. So next, we just have to consider the boundaries and access between zones. So for instance, it's logical to imagine that some privileged users in your IT segment would actually need to access the production network. This talk's going to investigate some of the barriers that are implemented so that only those intended users are accessing that zone. Okay, so starting off with some of the common implementations, their flaws and bypasses. So when I gave this to some of my friends to review, they mentioned that I didn't have enough cat memes. I ran into this meme at a different conference, and I can't stop watching it. You guys are going to Google this afterwards and stare at it for a while, I'm sure. So this is my cat meme transition slide. Just a quick note: I'm going to focus on a simplified version of these technologies for this talk. I understand that their actual implementation in the real world is more complex and nuanced. And so don't get distracted by just sort of quickness or low level of these. In terms of compromise, we're talking about exploiting many pieces of an environment, and we're not going to spend time on all of those. These are loosely broken up with the first few focusing on the network boundary and the rest focusing on the authentication boundary, just because I feel like identity management is the network segmentation of the 21st century. So the first solution I want to jump into is what I'm calling firecall. So broadly, firecall might describe any method to provide temporary emergency access to a secure system. I want to focus on those implementations where an organization allows or denies access through a network boundary through some sort of manual or automated changes to the network access controls. So maybe this takes the form of submitting a request to IT, or they change your network ACLs, or maybe something a little fancier. We have an application that makes dynamic firewall rule changes, some mixture somewhere in between those. So the first issue I want to talk about with this solution is a situation where an organization relies on manual firewall rule manipulation to control access between different zones. You have to think about complexity of management over time. So networks that start out in their design looking like this, with lots of great well-defined pieces and great network diagrams. Because of the challenge of management of these complex environments, over time they migrate from something that looks like this to something that looks a little bit more like this. And what I want you to consider is that having even one exception that permits access to a controlled network environment that you aren't aware of as an administrator presents a very significant risk. I think when you consider some of the exploitation scenarios, though, the security flaws present in the solution are a little bit more inherent to its functionality because these exceptions effectively create a bridge between zones. Sorry. So all an attacker needs to exploit this is to compromise a host as the beneficiary of the modified rules in the situation. And this bridge is easily traversed by an attacker, commonly referred to as pivoting. I think anybody who's read anything about hacking has probably run into that term at some point. So essentially, compromise of the low security zone means a direct path to the higher security zone. And just to kind of talk about a basic representation of this in a which you might see in a basic pen test, an attacker might start off by detecting holes, collecting network connection data from a range of target systems. And this is what we're demonstrating here is just the output of maybe a net stat. Then we want to use something like the super hacker tool grep to sort through that data to enumerate anything that might indicate the presence of this firewall exceptions. So, we've escalated, we've dumped net stats from a range of systems, and then we look to see, is anybody connected to a host that I want to be able to connect to? It's as simple as that. Then we just fall back to hacking class 101. We use Meterpreter to forward traffic through a compromised system. And this could be any sort of post-exploitation agent, or maybe using on a Windows system, NetSH, or there's lots of great possibilities. I just used Meterpreter in this example because it's fairly ubiquitous. So we use Meterpreter to forward traffic through our compromised system to the production network. Another situation to consider is if an attacker has compromised a machine that they know can or will access the target environment, they just need to create the situation where the firewall will be used in order to take advantage of this. And that's a pretty straightforward. I think anybody who's done a pen test or has been involved with the pen test has probably seen something like this happen. So,
First Hackfest. Cheers.
Cheers. All right, back to professional. Cool. So the takeaways here, like I said, I think that some of the built-in characteristics of this make it very hard to make secure. A couple of thoughts if you are going to use this as a solution, or if this is your solution at the company where you work. The smaller you can make the window of exposure, the better off you are. This setup seems to make the most sense for organizations where there's a very limited number of users, systems accessing those high-value assets. So you can place strict controls around them. A couple of thoughts limiting that exposure. Restrict client-to-client communications on the network. Do your workstations really need to be able to communicate with each other? Probably not. Any holes that you poke, build in automated close if possible. So shorter and more specific time windows where that exposure happens, the better. Regular testing and confirmation of segmentation. Consider, or maybe if you want to go to the next step, consider any administration of those high security zones to take place over some sort of true air gap. All right, up next, VPN. I'm sure this is a term that everybody is familiar with, but just to make sure we're all on the same page, just talking about a tunnel between your private network and a remote private network, probably over the internet. This is a very common for connecting production networks and remote data centers. And I felt like this was particularly timely because I've seen more and more production networks move all or partially into something like AWS. And those are almost always accessed over VPN. So the first implementation issue I want to talk about is the split tunnel. So with the split tunnel, we start with a network interface on our local LAN. It's pretty straightforward. Then we essentially are just adding another network interface that connects to our remote network. So this configuration effectively creates a bridge between the local and remote network. This is useful because it allows local network resources allow you to access local network resources while connected to your remote network, or maybe if you need internet browsing but you don't allow outbound traffic from that remote network, this is great functionality-wise. This is also useful to an attacker because this is easy to detect, and the exploitation error scenario is identical to that of a network where there is not a boundary. So what's the sort of alternative? The full tunnel VPN. This ensures that when the VPN connection is active, that the host no longer has connectivity to the local network, so eliminating that bridge. So security-wise, this is definitely a superior situation to the split tunnel. So for instance, We talked about using interpreter to forward traffic before. If we had some sort of post exploitation shell open on the target host, the VPN is activated. Pardon me. The connectivity would be lost when that VPN goes up because now we don't see direct access into that local LAN. While the full tunnel makes a bypass harder, it's still reasonably possible to get around. And I just want to cover how that might look. So one perspective to consider for the bypass is malware, or for a pen tester, we might call it a specially crafted post-exploit payload that can detect changes in network interfaces before firing off a connection to load additional post-exploit code from some reachable network, maybe something on the internet or something on some other internal network that allows inbound or outbound traffic that's allowed from our target network. So in this scenario, we need a target user that we know can access the secure environment. This might be something like review running processes on several hosts, so see who has a VPN client, what sort of network connectivity they have up, checking AD group memberships. So once we have our exploit crafted, we need to get it running. One way that I like to accomplish this is to use to create a service on the remote system and just have it run an executable. It's handy and it'll continue to run. And then we wait for our shell to happen. So in this scenario, we're just looking for some situation scenario to happen. So we see that VPN go up, or the network interface changes that we know about, and the binary is looking for that state change to happen. Once that happens, it does whatever we've sort of set it to do. So reaching out to whatever our target network is. Now, obviously, this takes a lot of recon and thought, but it's certainly possible. And then we've connected to our target network, so we're good to go. So takeaways. I think a theme that we're seeing here is once the attacker has administrative access to the system, the rest of the bypass is only limited by creativity. Just like with Firecall, if at all possible, we want to limit local network exposure of users that have VPN access to high security environments. Definitely want to avoid any situation where we're creating direct bridges between zones. So that's where that full tunnel comes in play. And multi-factor authentication without a band confirmation is certainly an option you want to consider in probably in any scenario, but plays well here. And I'll touch a little bit more on MFA in the next section. All right, so up next is Jumpbox. I don't know if I think different people use different terms for this, maybe some sort of bastion host, but Jumpbox seems to be the most common. So Jumpbox, for our purposes, is going to be a device that spans 2 dissimilar security zones. I think typically we see this built with SSH or remote desktop, depending on what technologies you want to employ. So this provides a nice way to implement a network boundary by restricting connections between zones to one or a few hosts, and also a place to implement an authentication boundary. So it gives you a way to do both in one solution. So the first sort of flaw or maybe implementation issue that we see here is what we call stale sessions. So let's imagine that we've compromised a user that has where they're using RDP to connect to our target zone. That user locks their computer and walks away for the day, or maybe they just go to lunch. If we compromise that user's system, or we already had access to it, when they walk away, we could simply log in. Now, in this compromise scenario, obviously if someone was to walk back to their computer and do something, they would see that I'm messing around with their desktop session, and that would be bad. That would be a giveaway, and that's kind of a game over. However, I think it's reasonable to imagine that you could script something up that would exploit this scenario in just a couple of seconds. So it's not like I'm going to sit there and play around with a remote desktop session all day. So the next implementation flaw I've encountered with this is just the single authentication zone. So just to go back to RDP, because it's so common, if we have one Active Directory domain that's controlling both of these zones. I think the most obvious problem here is that if you're authenticating with the same set of credentials to two zones, they aren't really two zones. So the attack surface can vary greatly based on exactly what the implementation is. But even if the use of the jump block provides an effective way to create a strong network boundary, one way an attacker might leverage this shared infrastructure in Active Directory is something like user logon scripts. If you're not familiar with logon scripts in Active Directory, it's essentially just a way to set something that runs when a user logs in. So you can assign tasks, and those tasks can involve something like an executable. So potentially we could design a script that will execute, and this would be something that we've generated, and we design that script so that it fires off some sort of additional code to our target host. And we just have to target a user we know is going to access the zone that we want to get to. So we're essentially leveraging Active Directory itself to do some of the work for us. So I mentioned MFA, multi-factor authentication. This comes into play, it seems like the most often in this jump box architecture. So this definitely strengthens that authentication boundary between the zones by making the exploit process far more complex. And we definitely recommend that this as a technology to use, but it certainly comes with its own set of implementation challenges. Like everything, MFA can be deployed in a way that makes it prone to attack or bypass. So one misconfiguration I've seen here when MFA is in place is making the MFA server itself accessible in the lower security zone. So just to kind of walk through an exploit scenario where this is the case, one port I like to look for during initial sort of scanning and enumeration is anything that's associated with MFA management. Like just for example, the RSA console has some specific ports that'll run on, or a signature that you can see with SSH. So if the management console is accessible from the low security zone, we just have to be able to log in, right? And kind of going hand in hand, part of the implementation problem is allowing logon to the MFA console using the domain credentials from your lower security zone, or maybe you don't have two separate domains. So in that instance, we already have our username and password. In any case, we target our user, gain access to the login. And I'm not going to say that getting credentials for something like this is a foregone conclusion, but typically by the time I'm ready to think about bypassing MFA, I already have the credentials I need, whether it's just targeting a local user and do some sort of brute force, or using 80 credentials that we've stolen through dumping entity s.did or something like that. So once we have our credentials, we can log in and do interesting things on the RSA console, like issue ourselves a soft token. And if we already have the credentials we need, now we can get past your MFA. If you're really interested in some stuff like MFA bypasses, this is a talk I highly recommend. This is a coworker of mine. He gave a talk at DerbyCon in Swift 2015 called Practical Attacks Against Multi-Factor. I definitely recommend looking that up. So just a couple of takeaways here. Consider the technical controls around how users access high security zones. For instance, session timeouts on remote desktop sessions. Consider the implications of compromise for critical systems. If you're not thinking about this from the assume compromise or assume breach perspective, you're missing opportunities to really secure and harden your systems. Okay, next up is VDI. So if you're not familiar with virtual desktop infrastructure, it's a solution that just lets you deliver applications or quite often full desktop environments. When it's used to deliver a desktop environment, it's essentially a variation on the jump box we just discussed. Just like the jump box design, VDI typically still violates a true separation of zones. So the first issue I want to talk about with VDI is the abandoned sessions without screen locks. So just like in the previous previous section, but I do want to mention it here because it's such a great attack. It's so common, it's so easy to use. probably maybe 30 or 40% of the time that we see somebody's using something like VDI or something like jump box, and we know that they're using something complex like MFA, we want to start with the low tech attack to get around those. And obviously, if they're doing cool things like timing out sessions and their users are locking out the screens, then we'll move to something more complex. But again, that's less common. We don't see that very often. So the issue I want to talk about with VDI is insecure session brokers. So the scenario here, we've compromised a host that you see is connecting to the secure environment via something like the Horizon client, which is VMware's VDI client. One of the interesting settings that an attacker might observe here is the ability to have the client not verify certificates, so you won't even get an alert. So we know that we can't rely on users to stop trying credentials because a certificate isn't valid, because we see that there's something untrusted here that the user's going to type it in anyway. So continuing down this exploit path, we can go to the settings for a user. Now I use the settings screen from Horizon client here, but these settings can all be done through the registry. So you could do this potentially without opening up a remote desktop session on your target user's host. So now we've set ourselves as the gateway. Now we just have to hack together some code to run a listener that captures their credentials so that it completes the session. So when the user types in their, normally we see that it's a username and then the password plus maybe their RSA token. So some combination of those. Once they type those things in and they hit enter, we will see them pop up on our screen. We can steal valid credentials. This would include that token value. Then we would reuse those to actually execute the login. I think that from a technical perspective, the user is probably just going to say, "Oh, that login didn't work," or "I fat fingered something," and they'll try again. But that will be fine because we'll already have the session open. We'll just cancel theirs. So another example of the flaw configuration here, I think that highlights the challenge of running complex network environments where high availability is critical. During the scanning portion of the engagement, we detect that there's 2 VDI servers. So again, looking for those ports that might be associated with MFA. But if we take a look, we actually take a minute to log in to take a look at the login for each one of those. Maybe one's a failover and doesn't require MFA. So this seems like a really obvious flaw, right? But this is exactly the type of thing that we see on pen tests that is this is low tech. We already have credentials and we just need to find the right way to log in now. So this is incredibly common. So just like other implementations covered, this solution violates that clean source principle we'll talk about that in just a minute, but it breaks that separation of boundaries in a way that lets us reuse credentials or abuse network connections. It's probably worth enforcing the use of signed certificates where possible, even on the internal network, even though I think most people don't like to do that. So I hate using the word cloud, but it kind of fit here. So the last concept I want to touch on is organizations that offload everything into the cloud. Service providers are hosting things like single sign-on or something for them. I've even seen people doing things like Active Directory in the cloud, which is great. So I've been fortunate to have the chance to do pen tests for several smaller companies this year. And in comparison to our standard large enterprise, this requires a very different approach in terms of pen test. So many of the organizations are in small offices that have little local infrastructure. So for the most part, they're just offices where people are connected. They're internet connectivity only. And so they manage things like user accounts, email, and data leveraging these third-party providers. So one of these that I ran into recently was on an internal pen test. They were using a single sign-on application that could tie together all the other service providers into sort of one dashboard for them. And I think that, I should see it here. I believe this one's actually called One Login. So this is really handy for users. It makes their lives easier because they log in once and have access to everything. This is also handy in terms for the penetration tester. So in this sort of exploit scenario, maybe we do some intelligence gathering, collect email addresses, figure out who the email provider is. That's, there's lots of really easy way to do this, but it might be as simple as just looking at the email headers. One handy tip here, I noticed that the Gmail login page is a great place for checking valid email addresses. So as long as you're throttling your request rate, you can just submit that and it will tell you if the email is valid. So if you have a list of like 300 potential names or names that you've compiled to just be potential users, you can turn that into a great list of actual email addresses. So we enumerate some list of email addresses. Now we just run a password guessing against that single sign-on application page. This is all very simple, and because it's exposed to the internet, you can do it from anywhere. And typically, they are less restrictive about how often, lockouts, or less restrictive about how many guess attempts that you can run. Once you find a valid login, just by looking at those responses in something like Burp Sweep, we get access to applications. And this is in this scenario, the sort of lateral movement piece is a little bit different than your typical pen test. It becomes an information gathering challenge. But if you have lots of applications, like GitHub is obviously a great one. You have lots of data. In this actual scenario, the first time I did this, I poked around in a code repo and found AWS API keys. And that's fantastic because, as you know, AWS might host all kinds of interesting data. With that API key, you can do things like download a copy of EC2 instances, and if there's data on there that belongs to their production network, then that could be a gold mine. So the takeaway here, the boundaries become very fuzzy and hard to define in this sort of cloud environment. If you're relying on these services to make sure you apply the same rigor to separating zones that you would on the more traditional enterprise network, and try to be very aware of where that authentication boundary is and managing those identities, particularly if it's exposed to the internet. All right, so the last piece, I just want to touch on a couple of secure design concepts, of things that I see that people do particularly well, make it hard to get around some of these solutions. So the first is the clean source principle, which I mentioned a second ago. I'll leave the sort of longer-winded technical explanation to Microsoft. If you want to Google it, it's really interesting reading. But the shorter version is, if an adversary can control anything in effective control of the target object, they control that target object. Because of this, you must ensure that all assurances for all security dependencies are at or above the desired security level of the object itself. Maybe the sort of watered down version would be, if an attacker can control an operating system, he has numerous ways to illicitly gain access to all the activity on that workstation and personate a legitimate account. So then they can abuse that workstation to get to anything that workstation can get to. I think this is pretty simple in principle, but applying this requires understanding control relationships of an asset, which gets pretty tricky when talking about some of the abstractions that live in something like Active Directory. So the modern threat environment requires an organization to adopt an assumed breach security posture when designing protections for high-value assets. So in other words, we approach the system security from the perspective that we've already been compromised, we just haven't discovered that compromise yet. You always want to consider the ramifications of compromise from the perspective of those privileged users and workstations. So if you've logged into a user's workstation with domain admin creds, then an attacker comes behind you, compromises that system, you've created potential for those credentials to be stolen or reused. So the question you have to ask is, can those credentials be used to gain access to your high security zones or more restricted assets? Secure Access Workstation, PAWS is the model that Microsoft uses. Again, if you want to Google that, it's really great reading. I love this model. Consider any system that access high-value assets as a special class system so that you can avoid cross-contaminating access privileges between zones. A couple ways to go about this. Maybe you provide a high-security workstation to your privileged users, so literally a second computer that they would access those systems from. Or perhaps you leverage virtualization. So to accomplish this, if you're using virtualization, it's critical that we're never logging in to the lower security system to access our higher security system, because that's when we violate that clean source principle. This is a big one for me. Just as a pen tester, I see that admin creds are abused or employed in a way that make them easy to gain access to. Um, so the security of most or all business assets in an organization depend on the integrity of the privileged accounts that administer and manage IT systems. So securing privileged access is a critical step in establishing a security assurances. Um, Basically, lots of admin credentials, and admin credential use means lots of chances for an attacker to capture those privileged accounts. So a couple of things to consider there. Know where your administrative privileges are being used. Again, the inventory principle, don't cross-contaminate. Limit role privileges to the minimum required. Limit the number of hosts on which administrative credentials are exposed. And ensure that administrative tasks are not performed in hosts used for sort of standard activities like web browsing. Poking holes to your high-value assets. One critical thing to consider is any design complexity of management. So juggling the demands of environments can be a pretty massive challenge. Many of the flaws that I find during a pen test tie back to like this one change they made for this one guy named Henry in marketing that one time, and then we never put back. Those exceptions can add up, and bad guys are very good at finding them. That's it. It's almost like the definition of my day-to-day job is finding those exceptions. One approach I think to this challenge is using something like concepts that are being developed in DevOps right now to manage changes. So creating strictly defined programmatic methods for managing system and service configurations to ensure that even if something gets changed to some insecure state, that there's some automated thing that a control that put it back into the more secure state. Okay, so kind of as a little bit of a wrap up, my goals are to present a secure architecture from the bad guy perspective and give a little bit of insight that I've seen, that I've gained through lots of sort of big enterprise pen tests for problems that we see and we like bypass normally. Again, just kind of addressing some of the shortcomings here. The reality of any implementation is very complex. I think you could write probably a whole book about some of these these topics, and that would be probably good books. I had to water these down for these purposes, but hopefully I still gave you that sort of attacker perspective on bypassing these solutions. Cool. So my favorite part about going to a conference and giving talks is the people that I tend to meet after I do a presentation. I get to learn lots of new things because everybody has their own perspective. So you guys have probably all seen these solutions in place in ways that I haven't or have interesting perspectives on them, and I take that and use it in my work. And I please come talk to me afterwards or ask a question or whatever. And please feel free to add me on Twitter or send me a message. I always like to have discussions.